we have a car moving at a speed of 40 kilometers per hour, and it is to be stopped by applying brakes in the next 4 meters. If the car weighs 2,000 kilograms, what average force must be applied on it? So very roughly, you have a car, and this car is moving right now at 40 kilometers per hour. And the nice way to begin this problem will be to convert this 40 kilometers per hour into SI units, that is in meters per second. And to do that, you will multiply by 5 over 18. And so you will get 200 over 18 meters per second by doing this, by this multiplication. You can further simplify that. That will be equal to 100 over 9 meters per second. But from this velocity, it's given that from this velocity, you need to come down to 0 meters per second to brake in the next 4 meters. And what average force means, you can just assume a constant force being applied, so that it means a constant acceleration being applied. And then, due to this, you can apply the equation v squared minus u squared, where v is the final velocity, u is the initial velocity. That is equal to 2 times a times s, where a is the acceleration and s is the displacement. So we'll just now input everything, and we need to find the value of a. So v right here is equal to 0. So 0 squared minus 100 over 9 squared, 100 over 9 squared. That is equal to 2 times a times s here is equal to 4 meters times 4 meters. And this here is in meters per second squares, since meters per second is squared. You don't anyway need that since it's all in SI, but you can include that. And if you solve for this, you get a to be equal to negative of 100 squared will be equal to 10,000 over 81. And since there was 2 times 4 here, there was this 2 and 4 here, you need to include 8 here. And the answer will be in meters per second squares over meters, this meter going there. So you will have meters per second squared, And from this, you can get that a is equal to negative of 10 to the power 4 divided by 81 times 8 meters per second squared. Now this negative signifies that the acceleration will be deceleration. It will be in a direction opposite to the motion of this car. And now you know that the car weighs 2,000 kilograms, and to find the average force that will act on it will be to find the sum of all forces acting on it, and that is equal to mass times acceleration. And mass is equal to 2,000, and acceleration is equal to negative, so I'll include the negative sign outside, negative of 10 to the power 4 divided by 81 into 8. And the units will be kilograms times meters per second squared. This is equal to Newton. And here, if you see carefully, this will divide this. You will get 250 here. And if you write that a bit more in scientific notation, you will get, if you divide 250 by 81, you will get somewhere in the vicinity of 3.1, and that multiplied by this 10 to the power 4, so 3.1 into 10 to the power 4 newtons in the negative direction, that will be the answer.